In this episode, tracks and the city, uniquely urban challenges,
some of the deepest tunnel in London. Crossrail is Europe's biggest construction infrastructure project.
and the ingenious solutions.
When the train moves, it has to swing.
When the freight gets onto the barges, there's this loud of the metal moving.
That make the impossible possible.
Lisbon without trams will be like Venice with no gondolas.
Despite being able to cover vast distances quickly and efficiently, railways aren't only used for epic cross-continental journeys. For more than 150 years, railways have been serving the world's cities, keeping them functioning, getting us to work, ferrying tourists to attractions, goods to market. They are the arteries that keep many great metropolises alive. But the urban environment poses a very distinct set of problems.
New York City is one of the biggest and busiest in the world, and yet incredibly, it's cut off from the supply lines that serve the rest of the country.
We're in London and you're mining in clay, which is a softer material. It does have a tendency to squeeze, and obviously there's a lot of sensitive buildings up above us.
The terrain in Lisbon, it's difficult. It's the city of 7 hills.
And it's one such seemingly impossible city challenge that once faced the 19th century railway engineers of Germany. That's exactly the situation engineers were facing in Wuppertal, Germany. By the late 19th century, the booming centre had reached an all-time population peak of 400,000 and quickly needed an efficient mode of transport. But with its packed streets and uneven terrain, all but the most extraordinary railway would be impossible.
You cannot imagine Wuppertal without it. We need this noise. This is just like a melody to us, it's like a music.
The Wuppertaler Schwebebahn, literally Wuppertal's floating train, was opened in 1901 and is still carrying the local population through the seemingly impenetrable cityscape today. Including local guide Gisela Rohleder.
This railway is certainly one of the most unusual railways. It is in fact an ingenious design. Nobody could imagine to have such a masterwork of techniques here in our tiny town. It looked really futuristic.
This impossible railway is the brainchild of inventor Eugen Langen, who, unable to tunnel or disrupt the city streets, decided to put a monorail on top of the city's river.
It's designed for the city, for this narrow valley with no space. So it was possible to construct it rather all the way along above the river, not requiring any supplementary space.
Langen's design could straddle the river and nearby streets using a steel upturned V design, and so avoiding digging in the waterlogged land or demolishing areas of the city.
It has been constructed in a height of 12 meters with a steel frame having nearly 1,000 legs, something like a caterpillar.
Following the city's river was a brilliant solution, but threw up another challenge. The windy river route meant that a traditional monorail that rigidly straddled the track would not be able to cope with the centrifugal forces at speed. So Langen turned railway engineering on its head, flipping the cars under the line and giving the floating train's passengers a unique swinging ride.
When the train moves around the curves in the track, it has to swing. And it swings up to 15 degrees to the sides, depending which side we go in the curve. Just now, for example, we swing to that side, to the left. Now we go the other way around in the curve. We swing to the right.
It's like riding a bicycle, but upside down. As you can see, it's quite easy to put it into a slight swing.
That ability to swing is essential to the Schwebebahn's success.
The vehicle needs to swing because you can make tighter turns and the force of the passengers is very small. The system is unlike any other system in the world.
This unprecedented flowing motion would have been impossible without some inspired engineering on the train itself. Today, project manager Markus Schawate is overseeing essential works on the Schwebebahn's vital wheels.
We are in the workshop of the Schwebebahn. They're doing some maintenance today. Now we have to maintain here the wheels of the new Schwebebahn, and we have to remove one wheel of this complete set. So these wheels have a maintenance period from about 200,000 kilometers, and then the wheel has to be changed to be exchanged for a new one.
Positioned above the train, the design of the Schwebebahn's supporting bogie assembly, including its wheels, is unique. To appreciate this, you need a view you can't get from street level.
We are now on the top of the workshop, and we are actually above the track, and you see the bogies of the vehicles. You see gearboxes, the left and the right one, and in the middle the motor. The track is a normal railway track, as you see, and the wheel is quite different because the wheel has two edges. A normal railway wheel is different because it has only one edge, and there are two wheels on a normal railway system.
As the Schwebebahn operates underneath the single rail, this twin-edged wheel design ensures the train remains safely attached at all times. Throughout its history, this impossible railway has been at the heart of Wuppertal. The Kaiser himself travelled on board, along with thousands of commuters. And in the mid-century, one surprising traveller jumped aboard.
In 1950, we had a very particular passenger in the Schwebebahn. And this passenger was a little elephant baby, 3 years old and 650 kilos of weight.
With the circus in town, Baby Toofy's ride seemed a perfect publicity opportunity. But he didn't agree.
It started to panic after a few seconds because it was not at all used to the noise this train made. It smashed all the furniture and smashed as well the side wall of the train, so that there was a big hole in the side. And before reaching the next station, the elephant jumped out of the train into the river.
Happily, Toofy survived the fall and was undoubtedly more at home in the muddy waters of the Wupper. Today, around 25 million satisfied passengers ride the Schwebebahn every year. For Markus, its incredible popularity means it's time to evolve.
Most of the trains are in operation since 1972. Each train covered about 2.5 million kilometers. So it's time for a change.
When the upgrade is complete, the new 31-strong fleet will mean passengers will have no more than a 2-minute wait for their train.
The increasing of this service is because of the number of trains and the new technology. One train can drive closer to the next train.
The charm of the old stock is undeniable. But the future is bright.
So we are now on the new vehicle, and you see it's much brighter and more friendly. The difference to the old vehicle is that the windows are bigger, and even the seats are a lot of more comfortable. Yes, I've ridden it as a passenger, and it's quite beautiful, and it's very good.
Old or new, this groundbreaking railway is the making of this city.
Wuppertal without the Schwebebahn would not be Wuppertal. That would be something else. It belongs to Wuppertal since more than 100 years. That's one thing, Wuppertal and the Schwebebahn.
But Wuppertal isn't the only railway to take on the unique engineering challenges that cities throw up.
Once upon a time, floats like this would have absolutely clogged the waterways, but now this is the last of its kind.
The ones coming up had no traction to run over the hills.
There's more than one way to build an impossible railway. Cities are the setting for some of the world's most ambitious railways. These packed urban environments pushing train engineers to their limits, demanding innovative solutions.
It has been constructed with nearly 1,000 legs, something like a caterpillar.
To seemingly impossible challenges.
We've got one of the largest stations in Crossrail and the smallest space to build it.
To ensure that every day, millions make it to the heart of the metropolis. But for urban railways, passengers aren't the only priority. And if ever there was a city facing these problems, it's New York. With its streets gridlocked for hours on end, the city of dreams is a traffic nightmare. Rail haulage would be the perfect solution to take the pressure off the roads, but trains have a seemingly impossible obstacle to overcome. Water. Everywhere. Dr. Eric Lima is cruising just off Manhattan to discover how the resurgence of a novel nautical solution is helping the city solve one of its longest-standing engineering challenges.
New York City, with a population of over 8.5 million, is one of the biggest and busiest in the world. And so it needs a constant supply of food and goods and materials to keep it running. And yet, incredibly, it's cut off from the supply lines that serve the rest of the country, the freight rail network.
Although passenger trains can access the city, the many rivers surrounding the port of New York have made it largely inaccessible to freight trains. The majority of supplies arriving by trucks, stifling its already congested streets. But thankfully, one impossible railway is providing an alternative.
This is it. This is the New York-New Jersey railcar float.
An ingenious innovation that ferries track-mounted freight trains across a 4.5-mile stretch of the Hudson River.
They're just loading on the last of the rail cars right now, and then those tugboats are going to push it all the way across the waterway into New York City.
With a single rail car capable of carrying 4 lorry loads, the 14-car capacity of the float means it can do the work of 56 lorries in just one 45-minute crossing.
You can hear when the freight gets onto the barges, there's just this loud of the metal moving. Once upon a time, Floats like this would have absolutely clogged the waterways. You would have seen them going back and forth because it's the only way to get goods into Manhattan. But now this is the last of its kind that operates on the Hudson and one of the last in the world.
As an historic centre of commerce, New York's demand for railway freight stretches back to the 1800s. But faced with this watery archipelago, getting any goods into the city required an overland detour via Albany to the north, adding as much as 36 hours to the journey. It was Brigadier General and former railroad engineer Herman Haupt who first pioneered a more convenient solution. First used during the American Civil War, his simple barge, fitted with railroad tracks, was an inventive idea. But as engineers developed it for the Hudson River, achieving a smooth transition between land and barge posed a sizable problem.
Now this is a tidal river, and that means that the water level goes up and down, and the amount of weight inside of the freight car changes. And that means that the float is at different levels at any given time. And the tracks need to line up. They need to line up on land and the barge so that the freight train could roll seamlessly onto land.
The key to achieving this pinpoint accuracy is a structure known as a transfer bridge.
In really simple terms, this transfer bridge is the portal between land and sea. And I have a little model to show you how it works. And it's quite simple. We have a winch at the very top of the transfer bridge. Now, when the barge comes up, the winch can turn, moving along cables that I have represented here by strings, and it can raise or lower the tracks to suit the needs at the time. So you can match it up perfectly so that it becomes one continuous track.
The extreme engineering needs to cope with enormous forces, as the floating barge, loaded with heavy rail cars, twists and turns in the tidal river. But the system of giant hinges, combined with supersized steel toggle bars, transfer the huge loads through to the bridge's substructure and the earth below.
So this whole thing, it's brilliant.
At its peak, this creative solution for the city's railway transported 6,000 freight cars every day. Today, the railcar float shifts considerably less of New York's goods, but is still a crucial lifeline. And with plans afoot to float 24,000 railcars across the Hudson every year, this green alternative to the city's congested streets once more appears to be on the up.
And there we go. It just docked. It's completed its journey. It's going to do the same thing tomorrow and the day after. It's an amazing lifeline for New York.
But some cities have to find a completely different solution to overcome their train troubles.
The squeeze here at the moment. Last beam come down today, is it?
It came down yesterday.
Okay, cool.
As a small army of engineers in London are currently discovering. "150 years since the first beginnings of London's famous Underground Railway network, an extraordinary new engineering project is nearing completion.
Crossrail is Europe's biggest construction infrastructure project at the moment. About £15 billion. It's 10 new stations through central London, 26 miles of tunnel, some of the deepest tunnel in London, about 40 metres deep in places. There'll be 24 trains an hour, which is about 20% addition to the capacity in this area.
But building it in one of the world's busiest, most densely packed and historically important locations is far from straightforward.
So one of the biggest challenges we've got at Whitechapel is the amount of space to work in. We've got businesses, a school, residents, a sports centre on all four sides of the work. We've got one of the largest stations in Crossrail and the smallest space to build it.
In historic Whitechapel, once the stalking ground of Jack the Ripper, striking a balance between modern engineering and heritage is vital.
The old station is about 140 years old. It's one of the earlier stations. Our role is to take away the old station and form a new station that combines London Underground, Overground and Crossrail together.
As a nod to the past, sections of the old brickwork will be preserved. But removing the remainder of the old station is a painstaking process.
Because of the proximity of the trains at the moment, we've had to do all this work by hand. We can't fit a large machine in to do the demolition. So here it's all been done by hand and taken out in bags during the day.
But for this impossible railway, it's not just the overland works that put the city's heritage at risk. Navigating a railway anywhere in an historic city is a tricky business, even if the engineers go subterranean. All that tunnelling can leave the underground world like Swiss cheese, with potentially calamitous consequences. So how is it possible to build a complex underground system without toppling the national treasures above? Up the road from Whitechapel in London's Finsbury Circus is another huge problem facing project manager Jules Boyd and the engineers of Crossrail every single day.
On the screen here you can see this is a three-dimensional picture of the tunnels related to the surface level up here. This is the building above, and there's the two platform tunnels in the central concourse. And there's a band of London clay which extends just to pretty much the bottom of the tunnels to, what are you, 5 metres into the clay, is it? Something like that? It's about 8 metres into the clay.
The complex computer system monitors when London's priceless architecture is in danger of moving. And today, it's showing that action needs to be taken.
There's a settlement trough emerging under the building.
So, how do you stop the towers of London from toppling?
How many ports are you going to inject here now, roughly?
It will take just another of the many solutions.
We are underground. Most of the people doesn't know here exists.
The coffins would have been unloaded from the hearses here.
Dreamt up by the builders of the world's impossible city railways. Urban railways. Feats of engineering that face seemingly impossible challenges as they thread their way through saturated cityscapes. Connecting the capital east to west, Europe's largest construction project requires 26 miles of tunnels. The sheer scale of the challenge is huge, but at London's Liverpool Street, their engineers have a particularly delicate problem, as they dig directly underneath some of London's finest buildings. With any ground movement potentially catastrophic, project manager Jules Boyd needs a state-of-the-art solution. And it lies 20 metres beneath street level.
This is grouting at it at the east end of the job, underneath some of the works that we're doing, the tunnelling works. Above ground, you've got some of the sensitive buildings called London Wall buildings.
To rebalance any underground areas disturbed by the freshly dug tunnels, the engineers are using an ingenious technique called compensation grouting. Lasers monitor hundreds of points on the surface buildings. If they start to move, even slightly due to the settlement caused by the tunnels, the engineers simply pump a grouting solution into the area to counteract the effect. In the world above the workforce, grand Edwardian architecture is in danger of being undermined.
There's a settlement trough emerging under the building that they're compensating against, and they're about to start the programme for injection that happens twice a day. How many ports are you going to inject here now? How many different, roughly?
Today?
Yeah.
In the programme? How many boreholes in the programme today?
Cliff Kettle is the principal engineer in charge of the delicate grouting operation.
So down here we've got one of our two main injection plants. We've got one in each half of the gallery. Very viscous grout is being mixed at the surface. That gets pumped down the shaft, comes into a receiving tank here. From the receiving tank, each of these pumps is drawing off, and the pressure is being monitored here and the flow. Here we have our injection control cabin. Down here, the operator is able to see all the pumping characteristics, and he's also got a screen here monitoring what's happening with the buildings on the surface.
There are several sites across London just like this one. Pumping compensating grout into a spider's web of pipes and tunnels stretching out beneath the city streets.
We are standing in this tunnel here, and you'll see each of the holes in the sidewall. You'll just see the end, and this is the distance that they go into the ground underneath the tunnels. The tunnels are these lines below us. This is the Hammersmith and City line. These are the platform tunnels here, and you can see the holes cover pretty much all of the area above the tunnels below. And then above, you can see the road layout. So here are the roads, and these are the buildings that are being protected. This particular building here has a facade that's sitting on the ground surface. The back of the building is built on all of these piles here. It's one of the more technically challenging bits of compensation grouting, where two halves of the building are a different construction and behave differently.
Once this morning's delicate operation is complete, it will continue twice a day, every day, until Cliff, Jules and the team are confident the cityscape above is completely stabilised. Safeguarding history is crucial, but if there's one challenge facing almost all urban railway engineers, it's the geography of the city itself. Most cities inevitably have one thing in common. They were founded.
I name thee Londinium. Lovely jubbly.
And grew long before the invention of the railways. Which means no one chose their locations with trains in mind. Rivers. Swamps.
Uh-oh.
Hills and mountains.
Hello.
There's no end to the daft places
Goodbye.
that humans have chosen for their homes. Lisbon, founded in 205 BC, may have been brilliant as a port, but it's a nightmare for anyone planning a railway. It's known as the City of Seven Hills, a sprawling mass of windy historic streets and extreme gradients, which provide an exhausting daily climb for its residents. But one ambitious railway engineer thought he had a solution, and the key to its magic lies in a little-known space beneath the city streets, where museum director Susana Fonseca is getting special access.
Now we are in the machine room. Most of the people doesn't know that exists. We are underground.
This unassuming room is the secret behind a truly remarkable innovation that conquered Lisbon's inclines.
Here we have Lavra funicular, the first street funicular in the world. It runs for almost 200 meters in a very, very steep gradient of 25%.
It was the 19th century engineer Raoul Mesnier de Ponsard's inspiration to bring what is commonly used as a mountain railway to the city. Influenced by the trains of the Alps, de Ponsard's funicular replaced donkey power, whisking Lisbon's residents up this extreme gradient in a matter of minutes.
He thought it's the most perfect transport for our hills here in the city. And it worked just fine till today. And they are still reliable and they are still comfortable for making this journey through the hills of Lisbon.
This impossible railway's uncanny ability to climb defies belief. But its solution beneath Lisbon's streets is surprisingly simple. A single cable at the heart of an extraordinary system.
And here is the machine with the cable who made the counterbalance for the funicular to work.
The counterbalance is created as the cable rotates around two parallel tracks on the street above, connecting two trains, one travelling up and one travelling down.
The ones coming up had no traction to run over the hill, so the one who is going down makes the counterbalance for the one who's coming up.
Originally, this counterbalance was created by adding weight to the descending train. On board, a water-filled tank increased its mass, creating a large force through the cable, pulling the ascending train up the hill. To this day, 3 funicular lines remain, but de Ponsard's legacy doesn't end there. A fleet of historic trams nimbly negotiate the rest of Lisbon's hilly terrain.
People of Lisbon love the trams. It's a symbol of Lisbon. Everyone uses the trams, and we simply love it.
Unlike a conventional railway, the slimline cars are a perfect solution for the capital's tight, windy streets. The city is so passionate about them, modern articulated trams have also been introduced to serve Lisbon's flatter terrain.
We have about 60 trams and 10 million people a year using the tram system, and we are growing.
With this expanding network running almost 20 hours a day, the popularity of the trams is posing new problems for the city's railway engineers. Any maintenance has to be carried out in the dead of night.
Já mandou desligar? Está tudo desligado? It's 1:30 in the morning and we are just beginning, so this job will take at least 2 more hours. In railway, you always have to work at night because that's the time that we have no trams going around. We always have to have our eyes in our main goal, which is never, but never stop the trams.
With the whole tram system now electric, keeping it powered up through Lisbon's ancient streets is a constant challenge for senior engineer Pedro Palma.
Eu acho que eles tinham cortado este fio. Nowadays we have around 67 kilometers of line, and here we are replacing about 50 meters of contact wire. So all this curve is already worn out. Hopefully the new one will last another 5 or 10 years.
And with a new 2.5-kilometre extension to the tram network in construction, Pedro and his team are also part of the railway's future.
It's pretty exciting to be constructing new lines. If we have the right conditions, we can lay down up to 30 meters per week.
The expansion project may be cutting edge, but the team still use traditional welding methods, joining the sections of track with a series of box molds.
The material will be melted inside the box that is put around the rail. And then when we take these pieces out, there will be the new lines.
Once the molten metal is cooled, it's ground down, creating a seamless join.
Meta lá o pé em cima da tangente para eu ver onde é que ela está a bater. We have to be really precise about it. Millimeter precision, that's for sure.
As this latest stretch of line is weaved into the city's streets, the tramways are undoubtedly continuing to shape Lisbon's future.
I'm really thrilled to be part of this expansion because history is being made. For us, railway engineers, to build as we do, it's the most thrilling part of the job, and this is the real deal.
And for the capital's residents, Lisbon simply wouldn't be the same without its impossible railway.
Lisbon without trams will be like Venice with no gondolas.
But trains don't always breathe life into cities.
While we think of city commuters as zombies and the living dead, this station actually dealt with the real deal.
There's nothing normal about impossible railways. Cities, home to some of the world's most impossible railways. Feats of engineering taking on huge challenges. From uncompromising street layouts,
it is designed for this narrow valley with no space,
to incredible inclines.
It runs in a very, very steep gradient of 25%.
All to transport billions of us and the goods we need from A to B. Urban railways have a role to play at pretty much every stage of all our lives. And once upon a time, that literally meant from cradle to grave. Engineer Dr. Rhys Morgan is in London to discover how some innovative Victorians used the railways to help solve a rather macabre overcrowding problem. Between 1801 and 1851, the Industrial Revolution saw the city's population more than double to a whopping 2.5 million.
With an increase in the living, there was, of course, an increase in the dying, and soon London's limited cemeteries were full to overflowing. And with the literal pile-up of dead bodies causing outbreaks of cholera and disease, a solution was desperately needed.
With no city space to spare, the situation appeared impossible. Until two railway moguls came up with an audacious solution. Arguably the strangest train line in British history.
And this is it, the London Necropolis station. While we think of city commuters as zombies and the living dead, this station actually dealt with the real deal, sending thousands of corpses a year out of the city.
In 1849, Sir Richard Brown and Richard Spry proposed harnessing the power of the railway to relieve London's overcrowded burial grounds. They would purchase a plot of land in the suburbs to create the world's largest cemetery, and then custom build a railway in order to fill it. It would be called the London Necropolis Company.
We're round the back of the station now, and while things have changed over the years, we can get a good sense of what the plan was from this map. the coffins would have been brought in on the hearses through the road just around the back here. And then they would have been brought under a glass-covered driveway where all the pallbearers would have waited. And then the coffins would have been unloaded from the hearses here and then placed on a lift and then lifted a few stories up to track height. And now we're up at track height, and you can see the siding that joins the main railway line to go out to the country. And once the deceased were loaded up onto the train with around 60 other corpses, they would literally begin their journey to the afterlife.
The line took them on a 23-mile ride out of the packed city.
The Necropolis Railway wasn't just reserved for the so-called coffin commuters, but the funeral mourners themselves could travel along with their dearly departed to the cemetery for the burial, and then back on the train that evening, back into the city.
At the literal end of the line for the coffin convoy was the necropolis itself. Brookwood Cemetery, now a 500-acre site with almost 250,000 permanent residents. It was once the largest on the planet.
This is what remains of the platform at the South Station at Brookwood Cemetery. And it was here that the last coffins would be taken off the trains for burial. But because the hearse carriages stacked the bodies 3 high, getting the coffins from the bottom shelf up onto the platform proved to be somewhat difficult. So the engineers came up with a whole range of solutions. First of all, they had a dip in the platform. Now, things have changed here, unfortunately, over the years, but you can just make out here where there's a definite dip where the bricks come down. And that would have helped bring the coffins up from the bottom shelf. They also came up with another ingenious solution, which was to change the shape of the bricks from the sharp edges here to much more rounded, and that would help pull the coffins up onto the platform. You could say it was easing the way of the departed to the afterlife.
Brookwood first opened in November 1854. And given the almost unlimited space in the area, initial plans were for the necropolis to become London's one and only cemetery.
Here at Brookwood, it was hoped that the vast 1,500+ acres of land would be enough to hold the city's dead for an almost indefinite period. And while that wasn't the case, by 1939, it had had over 200,000 burials.
The necropolis ran for almost 100 years, until its closure in 1941, bringing to an end one of the more unusual eras in British railway history.
The London Necropolis Railway provided what was undoubtedly a really successful solution to the city.
For over a century and a half, engineers have overcome huge challenges to build the world's city railways. Striving for innovation, developing inspired solutions.
Right outside of our daily lives, there's a whole secret system bringing all the goods and services that we consume to build that city right there.
Pioneering new discoveries, transforming our modern lives.
Every 3 minutes there is a train. If you lose one, no problem at all. Next one comes immediately.
They have succeeded in creating impossible railways.
There's no doubt that railways have transformed cities. They're altering our modern lives and they're shaping the future. Cities simply wouldn't be the same without them.